Now 29th A question is, prove that cos A plus sin A minus 1 whole by cos A minus sin A plus 1 is equals to cosec A minus cot A. So we have to prove this LHS equal to RSS. Let's try to prove it. So 29th A, right? First of all, let's take LHS. So what is LHS here? Cos A plus sin A minus 1 whole by cos A minus sin A plus 1. So in the required one, what is the required one? Cosec A minus cot A. So to get cosec A minus cot A, we have to divide both numerator and denominator with sin A. So such that we will get cot A and cosec A. Let's divide the numerator and denominator with sin A. So cos A by sin A. So I am dividing numerator with sin A plus sin A by sin A minus 1 by sin A whole by so denominator with us with sin A whole by cos A by sin A minus sin A by sin A plus 1 by sin A. So here cos A by sin A is cot A plus now here sin A by sin A, sin A gets cancelled. Now that will be equals to 1 minus now this one 1 by sin A is equals to cosec A. So same in the denominator place, cos A by sin A is cot A. Next this one sin A by sin A, so minus 1. Next this one 1 by sin A plus cosec A. Yes. So let's write in the order. Cot A minus cosec A plus 1 whole by cot A plus cosec A minus 1. So in the required in the RHS we have to prove what we have to prove. We have to prove it is equal to cosec A minus cot A. Cosec A minus cot A is a numerator. Cosec A minus cot A can be written as cosec A minus cot A by 1. That means this cosec A minus cot A is numerator. So when you want the answer in the numerator, just change the number. What is the number? 1. Only the number in the numerator place. So if you want answer in numerator, let's change that only. Do not change the minus 1 which is the denominator place. So change plus 1 that is in the numerator place only. So so let's take the third identity. What is the third identity? So from the third identity we have, what is the third identity? 1 plus cot square A is equals to cosec square A. So if you send cot square A right side, becomes 1 is equals to cosec square A minus cot square A. That means in place of this 1 we can write this one. In place of 1 plus 1 we can write cosec square A minus cot square A. So right here. So cot A minus cosec A. In place of plus 1 you can write cosec square A minus cot square A whole by cot A plus cosec A minus 1. Now it is equals to, now cot A minus cosec A plus, now this can be written as, this is in the form of a square minus b square. So that can be written as a plus b into a minus b. A plus b means cosec A plus cot A into cosec A minus cot A. A plus b into a minus b. So whole by cot A plus cosec A minus 1. So now this will be equals to, so what we can take common. So here we have cot A minus cosec A. Here we don't have cot A minus cosec A. Here we have cosec A minus cot A. So to get this one, let's take minus common here. So let's take minus common. So what it becomes? Cot A minus cosec A now take minus common here let's take minus common. So if we take minus common, it will become minus of cosec A plus cot A. Now this will become cot A minus cosec A. So whole by, so no changes in the denominator, cot A plus cosec A, so minus 1. Now so it is equals to, now take, here we have cot A minus cosec A, here we have cot A minus cosec A. Let's take cot A minus cosec A common. So if you take cot A minus cosec A, we will have 1 here. So 1 minus, here we will have this one. What is that? Minus of cosec A plus cot A whole by cot A plus cosec A minus 1. So to get cancelled, so we should have plus cot A plus cosec A minus 1. Here we have, after sending this minus inside, we'll get minus cosec A minus cot A. So to get this one will be equal to this denominator place. Let's take minus common again. So let's take minus common from the numerator. So if we take minus common from the numerator, now this, it will become plus cosec A minus cot A. Sorry, this will be as it is, right? Cot A plus cosec A. Now after taking minus common, now this will get cancelled, this will be reversed. That means here you will get plus cosec A plus cot A minus 1 whole by cot A plus cosec A. So now cancellation is possible. Cot A plus cosec A minus 1 cot A plus cosec A minus cot A plus cosec A minus 1 and cosec A plus cot A minus 1, both are same, so both gets cancelled. So what is the remaining thing here? We will get minus of cot A plus, sorry, this one is minus cot A minus cos, so this is equals to cot A minus cosec A, yes. So we'll get cot A, so here also cot A minus cosec A. Now send minus inside. If you send minus inside, it becomes minus cot A plus cosec A. Otherwise, we can write it as plus cosec A minus cot A. So this is answer. So next 29th B question is, if cot A plus cot theta plus cos theta is equals to P, cot theta minus cos theta is equals to Q. So we have to find P, prove that P square minus Q square is equals to 4 times of root PQ. So let's find it. So write what is given. What it is given? P is equals to cot theta plus cos theta, and Q is equals to cot theta minus cos theta. So what is required to prove? So we have to prove P square minus Q square is equals to 4 times of under root of PQ. So let's prove it. So first of all, we have P square minus Q square, right? Let's take LHS. So what is LHS here? P square minus Q square. So here P is cot theta plus cos theta whole square minus Q is cot theta minus cos theta whole square. So apply A plus B whole square formula here and A minus B whole square formula here. So A plus B whole square formula, A square cot square theta plus cos square theta plus 2AB. So 2 cot theta into cos theta. Next, minus of A minus B whole square cot square theta plus cos square theta minus 2AB minus 2 cot theta into cos theta. Yes, now this will be equals to cot square theta plus cos square theta plus 2 cot theta into cos theta. Send minus inside, minus cot square theta minus cos square theta plus 2 cot theta into cos theta. Now I think cancellations are possible. So where this is minus cot square theta, this is plus cot square theta. Now this is plus cos square theta, this is minus cos square theta. Now what is here? 2 times of cot theta cos theta, 2 times of cot theta cos theta. Now it will be equals to total 4 times of cot theta into cos theta. Now let's take RHS. So what is RHS given? 4 times of under root of PQ. 4 times of under root of PQ. So P is cot theta plus cos theta and Q is cot theta minus cos theta. So 4 times of, now this is like a plus b into a minus b. So a plus b into a minus b, a square minus b square, means you will get cot square theta minus cos square theta. So 4 times of this cot square can be written as cos square theta by sin square theta. So minus cos square theta. So it is equals to 4 times of, now multiply sin square theta into cos square theta. Now this will become cos square theta minus cos square theta into sin square theta whole by sin square theta. So from the numerator we can take cos square theta common. So here we have cos square theta, here we have cos square theta. Take cos square theta common. So cos square theta of 1 minus sin square theta whole by sin square theta. So from the first identity, what do we have? We know that sin square theta plus cos square theta is equals to 1. So if we send sin square right side, so cos square theta is equals to 1 minus sin square theta. So in place of 1 minus sin square theta here, you can write cos square theta. Let's write cos square theta. Now it will become 4 times of under root of cos square theta into cos square theta whole by sin square theta. Now, so here we have 2, so this square root and squares gets cancelled. So this square root and this square and this square and this square gets cancelled. So what are the remaining things? 4 times of cos theta into cos theta by sin theta. Now this we can write it as 4 into this one cos theta by sin theta into cos theta. So it is equals to 4 times of, or 4 into, so this one cos theta by sin theta is cot theta. So cot theta into cos theta. So this is equals to RHS. So this is equal to LHS. Sorry, LHS we have already proved it, right? So we have taken RHS and we proved it is equal to RHS. LHS, sorry. So what is LHS here? The same thing, right? Here LHS is equals to 4 times of cot theta minus cos theta. Here the same thing we have proved. So it is equal to 4 times of cot theta minus cos theta. So therefore LHS equals to RHS. Hence proved. Next question number 30. Alpha beta are the zeros of the polynomial px square plus qx plus 1. Form a quadratic polynomial whose zeros are 2 by alpha and 2 by beta. So what it is given here? Alpha beta are the zeros of this one. Let's write what is the given one. So p of x So p of x equals to px square plus qx plus 1. So if we compare this one with the general quadratic polynomial, what is the general quadratic polynomial? Ax square plus bx plus c. So the coefficient of x square is equals to p. So now a is equals to p here. The coefficient of x, b is equals to q, and the constant term c is 1. Now what is the sum of the zeros? Let's find the sum of the zeros. Alpha plus beta. We know that sum of the zeros is equals to minus b by a. Here minus b is q, a is p. So sum of the zeros is equals to minus q by p. Next, product of zeros. The formula is c by a. Here c is 1 and a is p. So it is equals to 1 by p. So we have to find a quadratic polynomial whose zeros are 2 by alpha. Let's find the sum of zeros. So 2 by alpha plus 2 by beta. So if you take 2 common, we will get 1 by alpha plus 1 by beta. Now cross multiplication. So if we cross multiplication, 1 into beta, so 1 into alpha. So beta plus alpha by alpha into beta. So this 2 into, now this is nothing but sum of zeros. Alpha plus beta or beta plus both are same. Sum of the zeros already it is what is it? Minus q by p. So write minus q by p here by, next this one product of zeros is equals to 1 by p. So it is equals to 1 by p. 1 by p. So now this 1 by p will go up and gets reversed. So it becomes 2 times of minus q by p whole into p by 1. So here pp gets cancelled. Now we'll have 2 into minus q. So minus 2q. So this is the sum of the zeros. Next, product of zeros. So product of zeros. 2 by alpha into 2 by beta. So 2 into 2 4. Alpha into beta is alpha beta. So here 2 by alpha into beta, we know that it is equals to 1 by p. So this 1 by p will gets reversed. 2 into p by 1 reciprocal. Now this will be equals to 2p. That's it. Product of zeros is 2p and sum of the zeros is minus 2q. So what is the formula to write the quadratic polynomial? P of x is equals to k of k some constant x square minus x of sum of the zeros 2 by alpha plus 2 by beta plus product of zeros 2 by alpha into 2 by beta. So k of x square minus x of sum of the zeros. So this is already we have found minus 2q, right? So minus 2q plus product of zeros. Already we have found it 2p. Yes, this one 2p. So now it is equals to k of x square minus x of minus 2pq. It will be equals to plus 2qx plus 2p. Here we did not get any denominator. So therefore the k value will be equals to 1 only, right? If k is 1, now it will be equals to p of x. The required polynomial is equals to x square plus 2qx plus 2p if k is equals to 1. So this is the required polynomial for the given question. Next 31st question is, so what is the 31st question? Rectangle ABCD circumscribe the circle of radius 10 centimeters. Prove that ABCD is a square. Find the perimeter of ABCD. So If a rectangle circumscribe a circle, we have to prove it is a square. Then after that, we have to find the perimeter of the square ABCD. First of all, let's find it is a square. The rectangle that circumscribe a circle is a square. So let's draw the figure. A rectangle that circumscribe a. So here ABCD is a rectangle. So each angle will be 90 degrees, right? So the circle is of radius 10 centimeters. First of all, we have to prove it is a square. Then we can find the perimeter of square. So first of all, required what is given here. So it is given that this ABCD is a rectangle circumscribing a circle of radius 10 centimeters. So this is the first one, and radius of circle is 10 centimeters. So what is required to prove? We have to prove it is a rectangle, sorry, square. So we have to prove this ABCD is a square. So let's prove it. We know that when any quadrilateral circumscribe a circle, sum of the opposite sides are equal. So if a quadrilateral circumscribe a circle, any quadrilateral, if a quadrilateral circumscribe a circle, then the sum of the opposite sides are equal. Then the sum of opposite sides are equal. So what are the opposite sides here? AB, DC, AD, BC. So we will get AB plus DC is equals to BC plus DA. So but opposite sides are equal in a rectangle, right? Now AB. So in place of DC, you can write one more AB because opposite sides are equal. Now BC. In place of DA, you can write one more BC because opposite sides are equal. Since AB is equals to DC and DA is equals to BC. So since opposite sides are equal, so we can write like this. Now we have 2 times of AB is equals to 2 times of BC. Now 2 to cancel. Now we will have AB is equals to BC. So therefore that means the adjacent sides are equal in the rectangle, the above rectangle. So therefore when adjacent sides are equal, then all sides will be equal. Therefore you can say that AB is equals to BC and BC is equals to DA and AB is also equals to this CD or DC. So therefore all sides are equal. Therefore this ABCD is a square. So when ABCD is a square, then we have to find the perimeter, right? So let's redraw the figure here. So A, B, C, D. Now join B and D. Here O is the center of the circle. So let us think this is P. So O to P is 10. The diagonal of the square bisects the angle at the vertex, means angle B is total. How much? Angle B is total 90 degrees. So it will bisect. It will be equals to 45 degrees. So and angle at P is 90 degrees because the angle between the tangent and is 90 degrees. So and we know that X is OP is 10. So let's find this BP by applying tan 45. So from triangle OBP, let's apply tan 45. So with respect to 45, opposite side is OP, adjacent side is BP. So uh, tan 45 is 1. So 1 is equals to OP is 10, 10 by BP. So BP will come left side becomes BP is equals to 10 centimeters. If BP is 10 centimeters, then BP is half of BC. So BC will be is equals to 2 times of BP. So 2 times of BP means 10. So BC will be equals to 20 centimeters. That means side of square is equals to 20 centimeters. So therefore perimeter of square is equals to 4 times of side, 4 times of one side, any one side BC. So 4 into 20, that will be equals to 80 centimeters. So we can also find the side of square like this. See, side of square is nothing but the diameter of side of square is equals to diameter of circle. Side of square will be equals to, so diameter of circle. You can also find like this, diameter of circle. So radius, so diameter is 2 times of radius, right? So 2 times radius is already 10 centimeters. So 20 centimeters. So that is how we can also find the side of square is equals to 20 centimeters. Then perimeter is equals to 4 into side, 4 into 20, which is equals to 80 centimeters. So this is 80 centimeters, right? 80 centimeters.